Hey gang, here is your video for extra notes for special right triangles. Yay! So since I can't be here with you, I decided to make a video for you just for me, which I hope will help you better understand how to work these little puzzles because that's all they really are. So 45, 45, 90 triangles are isosceles, so the two legs are the same. And by virtue of the Pythagorean theorem, it just so happens that every time you work one of these, the same pattern arises. So if this is a 5, this is a 5, and therefore this is 5 times the square root of 2, just like the pattern you see up above. Secondly, if you have a 30, 60, 90 right triangle, you know what, let's use the same number actually. If it's a 30, 60, 90, which actually grew from half of a equilateral triangle. If this was a 5, this would be a 10, and this would be 5 square root of 3. So notice the difference in the two types of problems. Notice two equal sides, square root of 2 right here. Three different sides, and this has a 30-degree angle. Next to the 30-degree angle is the side that's the small side times the square root of 3. You'll also notice this is twice as much as this, and that's just because this is actually half of a big triangle. So if this is 10, this is therefore half of it. But most people find it easier to do this work by starting small and going big whenever possible. Just like here, you'll often hear people say the pattern here is x, 2x, x square root of 3. But for 45, 45, 90s, you'll often hear x, x, x square root of 2, because these are the same. Even though they're the same, you'll often hear people say x, x, x square root of 2. So let's do some 45, 45, 90s. Go to the examples. Oh, wait, but before we get there, good reminder that this is very helpful. And remember, if there happens to be a number on top, you just bring it over, and this is still radical x over x. So a reminder, 7 over radical 2 is just 7 times the square root of 2 over 2, just like we did in previous cases last week. Also, if you happen to see a radical that can be reduced, go ahead and reduce it to save you some work. Same thing here. You'll see division by radical 3 and division by radical 2 on a whole bunch of these when you have to go from big to small. So let's do the 45, 45, 90s. You'll also notice on the worksheet that I copied the pattern several times around the page to make it easier for you um, to remind you, but it really helps. You'll get much better at it if you actually write the pattern every time. I'll write it sometimes. So here's our first one. You should copy these as I do them. If not, work slightly ahead of me if you understand what's going on. So this is 9, 9, 9 square root of 2. So notice the legs are the same. Moving ahead to 2. The legs are the same, so this is 3 radical 2. And now the hypotenuse is the leg times the square root of 2, which in this case would be 3 times the square root of 4, which is 2, and therefore 6. So the hypotenuse is a beautiful little 6. And how did that happen? Because these made the radical go away. So to make the square root go away, you have to multiply by. You have to basically square something. That will come in handy later. So let's do another one. 5, 5, 5 square root of 2. Don't complicate it. Go to number 4. Now we have to go from big to small. And here's the pattern again. X, X, x square root of 2. Well, that makes this one a little easy because that means that this is 3 and so is this. You don't even have to do any math there really as far as dividing, but if you wanted to, you could just divide by the square root of 2 and that would go back to 3 because the pattern to go from big to small, you actually have to divide. You would divide this by the square root of 2 to make this disappear. Either way, that one's a little not too bad. Now this one's a little bit more challenging because, again, the pattern is x, x, x square root of 2. So we have x, x, x times the square root of 2. So if I have to divide this by the square root of 2 to get back to where I started, that is just the square root of 5. Inside divided by inside. Therefore, this is also the square root of 5 because they're both the same as its isosceles. Now this one is a little bit more complex. You'll notice I drew the triangles for you in that direction. So you'll notice here that this is a hypotenuse. So in order to go backwards, you'll notice here's the hypotenuse. I have to divide that by the square root of 2 to get the legs. And you'll notice this leg is actually a hypotenuse as well. So we're going to take that one step at a time. So if we divide this by square root of 2, we get 7 radical 2 over 2. And therefore this one is the same. Now let's look at that. So what this says is this side is something times the square root of 2. You may be saying, hey, how do I divide that by the square root of 2? It's not as bad as it looks. You just have to put that square root of 2 on the bottom, just like you would do that here. You put the square root of 2 on the bottom. Let's clean that up a little bit. You would divide, let's clean this up. You would divide this by the square root of 2. So let's see what that mess looks like. It should be complicated. It's the last question. 7 radical 2 over 2 over the square root of 2 because we're dividing by the square root of 2. So it looks like these disappear and I'm left with 7 over 2, which means these two little guys are 7 over 2, which means these little guys are 7 over 2. Let's see if that makes sense. This times the square root of 2 would be 7 radical 2 over 2, which means this and this are 7 radical 2 over 2. And as you might recall, that gets us back to our 7 here because 7 radical 2 over 2 times the square root of 2 equals 7 times 2 over 2, which is 7. So it's right. So just a quick recap of this challenging one so you don't freak out on me. So if this hypotenuse is 7, this is 7 over the square root of 2, which is 7 radical 2 over 2, and therefore so is that one. And if this hypotenuse is 7 radical 2 over 2, then this leg is this over square root of 2. Because, again, to go smaller, you have to divide by the square root of 2. The easiest way to do that is to just simply put it on the bottom. And then you'll notice those cancel out, and you get 7 over 2 for those. I do expect you to try those practice problems. Now, you do the practice problems for the 45, 45, 90s. Check with a friend. And then, when you're done, go to the 30, 60, 90s. Okay, here we are at the 30, 60, 90s now that you've tried the 45, 45, 90s, and you'll notice the pattern is a little bit different because it's a different kind of triangle. This will happen a lot next year too. So if I double this, I'll get the hypotenuse. Notice the pattern. The little guy creates the big 2. And this, therefore, is 1/2 times the square root of 3, but that is usually written as the square root of 3 over 2. It looks ugly, but it works. And that is your absolute basic 30, 60, 90 triangle with a hypotenuse of 1. So let's do it again. Here's the pattern. Short side, double it. Short side times the square root of 3. And for some of you, it may feel more comfortable to actually write 1 square root of 3. But in an answer key, you'll see it as square root of 3. Okay, little times 2, little square root of 3. Here we go. Ready? So here's the pattern. Looking at it again, if I want to go from here to here, then I need to divide. So 18 divided by 2 is 9, and now 9 radical 3 is the long leg. Let's do that again on number 14. Divide that by 2 to get the short side, because the short side times 2 is the long side. And now take the short side and multiply it by the square root of 3, and you are done. Now you have all 3 sides of the triangle very quickly. And I'll walk you through that again. Ready? So if the pattern is 2x, x, so take this, divide it by 2, we get 7 over 2. Notice we stay as a fraction. Now, the short side times the square root of 3 gives you the medium side, or the other leg. That's a 2. Okay, so here's another one, number 15. Now, again, the pattern is x, 2x, x square root of 3. I gave you a relatively easier one here than you can sometimes see. So you'll already see the x right there. So that means that this side right here is 2, and this side is twice as much. I'll put these in color. I'll clean it up so you can see it better. So that was your 2x. So if that's x square root of 3, then this must be 2, and this must be 4. And again, that's because this is a whole triangle. So if this is 4, this little guy is half of it. And that's why you've got this 2, 4, and then this happens because of the Pythagorean theorem. And it works out to that every single time. Let's do one more. So if we divide this by the square root of 3, we'll go right back to where we started. So we could have done that over here too, but we didn't have to because it was right in front of us. But just in case you don't notice it, to go down, you divide that by the square root of 3, then go back up to get the hypotenuse, and you are done. So again, it goes like 1, 2, 1 square root of 3, 2, 4, 2 square root of 3, 3, 6, 3 square root of 3, and so on, and so on, and so on. So again, 30, 60, 90. The short side is your base. Everything's based on the short side if you want the work to be easy. Okay? It's that simple. So you go ahead and do the practice problems. And then check with a buddy. And when you're done doing that, go back to the practice problems here, and you can check your answers for the 45, 45, 90s. So that's 5, 5, 5 square root of 2. square root of 2, square root of 2, square root of 2 times the square root of 2, which is the square root of 4, which is 2. And number 9. So it goes x, x, x square root of 2, which means these had to be 10s, because 10 times the square root of 2 is 10 radical 2. And number 10, so if this is 8, this is 8, this is 8 square root of 2. Therefore, the other leg is 8 square root of 2. Therefore, this hypotenuse is this times the square root of 2. So you get 8 times 2, which is 16. So you'll notice when you have two 45s, you started with 8, then you got to 8 times the square root of 2, then you got to 8 square root of 2 times square root of 2. And now here's your key for the 30, 60, 90s when you're ready. So short, double the short, short square root of 3. So we got x, 2x, x square root of 3. X, 2x, x square root of 3. And you can keep the pattern in front of you when you do it. You can see it better on your screen. So checking your answers. If that's 4, that's half of it. And that's that times the square root of 3. You can check it. 2, 4, 2 square root of 3. 18, 9, 9 square root of 3. Now, dividing this by the square root of 3 to go backwards, this has to be a 5 because 5 square root of 3, 5 times the square root of 3 is 5 square root of 3, and therefore the hypotenuse would be 10. And you'll see I even drew this over here to help you. Okay, find the short side. The other leg is x, so this is x square root of 3. Notice you can see the 10 right away if you write it. Oops, and this is 10 times 2, which is 20. You don't have to write the times 2. We'll just put that there. Now, moving right along, let's see if we can do the one with 2 30, 60, 90s. Okay, so short hypotenuse. So x, 2x, x square root of 3. Now, if this short is 10, then this hypotenuse is 20, and this leg is 10 square root of 3. Notice what happened. We had 5, 10, 10, 20. So we have 5, 5 square root of 3, 10 square root of 3. So everything doubled in size. Isn't that interesting? So let's do one that has both kinds of triangles. So I put the two kinds of triangles next to you. So we have 10, 20, 10 square root of 3. So if that's the 10 square root of 3, then this is 10 square root of 3. So let's see. 10 square root of 3 times the square root of 2, because that's the pattern for this kind, equals 10 square root of 6. I hope you did well, and now you have enough tools to help you do the assignment I gave you a couple of days ago. So again, practice saying it in your head. X square root of 2, x, 2x, x square root of 3. I will see you all around school at some point today, most likely. And thank you, as always, for all your hard work. Peace. And just be ready to turn all this work in when you come in on Monday. So you've got this done. Now you should be able to go back and make sure you can finish the problems I gave a few days ago. All right, see you guys soon.